All right. By the way, Abdullah, I did told the team to schedule the class. Actually, the slot was not free today. Uh, Probably in the next class now, you guys will be called. Particularly you and Ronnie, you guys were having doubts in the chapter Age of Adolescence. So probably in the next class, before the next class, you guys will be called for the backup. Okay. Today we are going to continue with this chapter, that is sound. So in the chapter sound, we will be learning about what is sound, what kind of energy it is. uh, just like we know, light is a form of energy which enables us to see our surrounding. In the similar manner, we will learn that sound is also a form of energy because of which our ears are able, we are able to hear something. It's a form of energy. We will learn how it travels, just like we have learned about the sound. Just you guys would have learned about the light in the previous classes. That light travels in the form of waves. It travels in a straight line. So in this manner, in this chapter also, we will be learning about how the light will be traveling. Okay. Am I not visible? Okay. So we will learn about this. Further, we will learn about how sound is produced. How the sound will be produced by an object, we'll be learning about that as well. How due to the vibration of the object particularly, it will be produced. How we humans will be producing the sound. There particularly we'll be learning about the larynx, the vocal cords present in the larynx will be producing the sound. How the sound will be traveling. Propagation means the movement of something is called as propagation. So how sound will be moving in different mediums, how the sound will be moving in the solid, liquid, and in the gaseous medium, and does the sound travel in vacuum or not? These things we will be learning. Further, we will learn that there are certain terminologies related to the sound. When we will be learning that sound travels in the form of waves, so there particularly we'll be learning about what is amplitude, what is pitch, what is frequency. These things we'll be learning. Further, you guys have would have observed that certain kind of animals, for example dogs, they would be barking a lot. At certain time they'd be barking a lot. You'd have heard that certain animals would be able to sense the sound waves that are not audible to the humans. For example, the sound waves that are produced while an earthquake is coming. Okay, now while the earthquake waves still not have reached the surface, the animals would be able to hear those sound waves, and they would be making a strange sound. Getting what I'm trying to say? Khadija, Roni, Gauri, Chakrika. Is Abdullah not here? Is there someone who's still in the waiting room? Okay. So we will learn the audible range of the sound. Okay, now we will learn that you are able to hear the sound of a certain frequency only, certain frequency only. Further, we will learn what is noise pollution, and what are the problems caused due to the noise pollution and how we can reduce this. Also, we will be learning about the structure of the human ear in detail. You guys would okay. You guys would be now learning about very interesting facts while we will be learning about the human ear. Okay, you guys know that there are tiny bones present in our ears, also inside the ears.
Yes, sir.
Yeah. Okay, and they are the smallest bones present in our body. Where is the longest bone present in the body?
Sir, the female.
The femur bone, or also called as the thigh bone. Thigh bone. Okay, now all of you turn your cameras on in the class. By the way, all of you turn your cameras on in the class. Rooney, is your audio issue resolved or not? Abdullah, are you facing some network issue today? Yes. Guys, everyone turn their cameras on in the class. I was asking, like, is there some issue with your audio? Are you having difficulty in connecting to the mic, Ronnie? Okay. So talking about sound, so we see that sound is a form of energy. What is it? It is a form of energy, and it helps us to communicate with one another, and it plays an important role in our daily life. So it is first thing is we are saying that it is a form of energy. form of energy, which because of which our ears are able to hear something. That is one thing. And one cannot create sound or one cannot destroy it, but you can just transform it from one form of energy to another form of energy. For example, try to understand it in this manner. Try to understand it in this manner that when a cell phone rings, the sound is produced, and how the sound is produced, it is converting the electrical energy into the sound energy, isn't it? So one
Yes.
form of energy has been converted into another form of energy. By the way, in general, we know that if even if we were not to discuss about the sound energy, in general, what we know that energy is conserved. Energy cannot be destroyed. It is just changed from one form to another. Like for example, take a cell, take a battery. How what kind of energy transformation takes place in a cell or a battery? There the which kind of energy is transforming? Yes, the
Chemical energy.
chemical energy is transforming into the electrical energy right now. So you guys would be learning about conservation of energy, laws of conservation of energy in the later classes. And the laws of conservation of energy basically says that energy is neither created nor it can be destroyed. It can only be transformed from one form of energy to another. So law of conservation of energy is applicable for sound energy also. Getting it, guys? It is applicable for sound energy also. So it is applicable. It also follows the law of conservation of energy. Let me repeat what I said about law of conservation of energy. Law of conservation of energy basically says that energy, it is neither created, neither destroyed, neither created and nor it can be destroyed. But what happens? It just changes its form from one. It just transformed from one form to another, like the case of the transformation of energy or transformation of chemical energy into electrical energy, or vice versa. That is one thing. So sound is considered as a form of energy, and it follows the law of conservation of energy. So when sound is produced, the energy will be transformed from a vibrating object into the surrounding medium in the form of waves. As you guys can see here, for example, due to the vibration of the membrane here, due to the vibration of the membrane of this drum, what is happening? The energy from this membrane is being spread into the surrounding in the form of sound waves. Take a look at this one here. As this object is vibrating, due to the vibration of the object here, the energy from this object is being transferred to the surrounding in the form of sound waves. Everyone getting it what I'm trying to say? So when sound is produced, energy is transferred from its source, that is here the source is the vibrating object, into the surrounding medium right now. That is one thing. So it is a form of energy, and it can not be destroyed. It cannot be destroyed, but it is transferred. It is transferred. Okay, na? It's basically we'll be saying that it is transferred. And the basic principle of production of sound is that any object that will be vibrating, the sound will be produced. The basic principle of production of sound is that due to the vibration of the body, sound is produced. So let us understand this further in detail. So these are some of the common musical instruments that we see here. These are the common instruments: string instruments, winds and brass instruments, percussion instruments. Right now, the instruments that will be producing the sound due to the vibration of the string, they are called as the string instruments. The instruments that will be producing sound because of the wind that is blown in it, the air that is blown on it. So due to the blowing of the air, the sound is produced from these instruments, and the example, they are the winds and the brass instruments. And when the metal plates are strike against one another, so thereby due to the striking of the metal plates, sound is also produced, and those instruments are called as percussion instruments. Nonetheless, what I'm saying that in all these things, what is going to happen? Vibration is happening. Take for example this drum. As we are going to hit the drum, so what happens? the molecules of the air that is above this now, they also start to vibrate. They will start to vibrate, and they will start to collision will start to take place between the molecules. Collision will start to take place between the molecules. Take a look at this animation here. What is happening here? And you can see that how the molecules, these dots that you see, these are representing the air molecules. Getting everyone? Chakrika, Gauri, Khadija, everyone.
Yes.
So the air molecules starts to vibrate against each other. They start to vibrate. At some places you will see they will be coming closer. At some places they will be going far away from each other. So due to the vibration of the air molecules, the sound will be produced. So where you will see that they seem to be coming close to each other, that will be called as compression. And where they are getting far away from each other, that is called as rarefaction. Let me draw this. If the air molecules are away from each other like this, so that is called as rarefaction. What do we call this? That is rarefactions. Okay. And when they come close to each other, then that will be called as, if they are coming close to each other in this fashion, that will be called as compression. So due to the continuous rarefaction and the compression, the sound will be traveling in this manner. So that is called as compressions. Compressions. So here what is happening, due to the vibration of the air molecules in the form of rarefaction and compressions, the energy from this vibrating object, the sound energy, the energy from the vibrating object is transferred to the ears in the form of sound. In the form of sound. Is that clear to everyone what I'm saying?
Sir, can you explain again?
I mean, saying that due to the vibration of this object, the air molecules that is surrounding this object, that starts to vibrate, and that starts to vibrate in the form of rarefaction compressions. Rarefaction is when the air molecules would be away from each other, and compression is when they will be coming closer to each other. So in the form of rarefactions and compressions, the sound energy is transferred to our ears. The sound energy is transferred to the ears, and here a medium is required, and the medium here is air. Getting it up? So that is how the sound is produced. It is produced due to the vibration of the given object. It could be the membrane, for example, in the case of this drum. It could be the membrane of this. In this case, it could be the percussion instruments. It could be the metallic plates here. Getting it? So that is the basic criteria for production of sound. So far what we have learned, that sound is a form of energy because of which our ears are able to hear something. One cannot produce, or one cannot destroy the sound. This statement basically means that while I'm saying that one cannot create sound or destroy it, so it is actually following the law of conservation of energy. As per what we have learned, that energy can neither be created and neither can be destroyed. Is this a statement clear to everyone? The law of conservation? Yeah.
Yes, sir.
Okay. No? So why I'm saying that sound cannot be created or destroyed? Because it can only be transformed from one form of energy to another. Right now, because when we'll be learning about different laws in the high classes, they, for example, just take daily life examples. When a cell phone rings, the electric energy is converted into the sound energy. Or when you will be hitting the ground with a brick or with a ball, so some of the ball's energy is converted into another energy, and the rest of it is released in the form of sound energy. Like for example, if I am holding a ball in my hand, I am holding a ball, and I'm going to now drop it, and then it is going to hit the ground. Now you guys know about this basic thing, I suppose, that anything that is in rest, it is said to have a potential energy. Right now, while I am holding this ball in my hand, it is having a potential energy. It is having some potential to do work. Getting what I'm trying to say? While an object is at rest, it is having a potential energy. But the moment I will be releasing it now, the moment I release it, then it gains. Yes.
Then if you release it, it will be a non-potential.
Non-potential, or more appropriate to say, it is kinetic energy. At that time, it is having kinetic energy, right? So anything that is in motion is said to have a kinetic energy. Getting it, everyone? What I'm trying to say? So, like whether you guys are running or a car is walking on the street, any kind of object that is in motion, that is said to have a kinetic energy. Okay, now, and if it is in rest, that is said to have a potential energy. Let me write this. So right now, this is having a potential energy, and while it is in movement, while it is falling, at that time it is having the kinetic energy. All of this is actually related. That's why I'm explaining these things. So while, yes.
Sir, I have a doubt. So, sir, does that mean space? We can't hear anything in space because you said that air is a medium for sound to travel to our ears. So,
Exactly.
does that mean we can't hear anything in space?
Exactly, because sound requires a medium, right? Now, medium basically has the molecules in it now. Whether it be the solid medium, liquid, or the gaseous medium, all of them have the particles in it. Liquid particles, gaseous particles, or the solid particles. But in the vacuum, you don't have any particles now. So if no vibration of the particles are going to take place, hence no sound will be produced.
So then, how do astronauts communicate even though they wear the special suit?
Yeah, they have devices now. Astronauts in the space would be communicating with the help of some special devices. Like you guys would be able, like a kind of walkie-talkie devices. Okay, no? So they will be using that. So they have certain electronic devices that are installed in their suits, that are installed in their helmets particularly. Getting it? And with the help of that, they will be able to communicate. Okay, no? So they have a very specialized communication equipment. Yes.
Yes, sir. Clear, sir.
Okay, no? Particularly, they will be using the radio microphones. Okay, no? Because radio waves can travel in the vacuum also. Radio waves can travel in the vacuum also. That is one thing. Now, coming back to this discussion here, that if I am having a ball, like previously I gave the example, you have a cell phone. How does the cell phone produces energy? There, what is happening? The electrical energy is converted into sound energy, right? And here, when the ball will be hitting the ground, so some of the ball's potential energy will be converted into kinetic energy. While it is falling, earlier it had the potential energy while I was holding it in my hand. The moment I dropped it, some of the potential energy converted into the kinetic energy, and other energy that is left, it was dissipated, or it was released in the form of sound. It was released in the form of sound in the surrounding. Getting what I'm trying to say? Let's say, for example, while I was holding that ball, it had 100 joule of energy, for example. How much joule energy it had? 100 joule of energy. While I released it, 100 joule of energy, by the way, this is potential energy. Getting it now? While I released it, some of it converted into kinetic energy. Let's say 80 joule converted into the kinetic energy. So where did the 20 joule of energy go? It will be producing some sound now when it will be hitting the ground, or will it not produce the sound? Gauri,
Yes, sir.
Roni, Abdullah, everyone, you guys getting my question? I'm saying that while I was holding it in my hand, it had total of 100 joule of energy. While I released it, what happened? While what happened, 80 joule converted into the kinetic energy. You guys know about joule now, it's the unit of energy.
Yes, sir.
So what happened to the remaining 20 joule? The moment it will be hitting the ground, it will be producing the sound energy. So that 20 joule converted into the sound energy. Getting what I'm trying to say now?
Yes.
So here what is happening here, that energy is basically transformed from one form to energy. It has transformed from one form to another. Okay, no? So one cannot create sound or destroy it, but one can transform one form of energy into the sound energy. So we had a given form of energy and we converted that form of energy into the sound energy. Like in the initial phase, think about this carefully. Like, did you guys created this sound yourself, or the potential energy, which was the earlier form of energy, converted into the sound energy? Like,
The,
did you
the potential energy converted.
right now? So there was a pre-existing energy in this. There was a pre-existing energy in this ball that converted. But in the first place, did you yourself invented this sound that is going to be produced by the ball? No.
No, sir.
Just one form of energy transform into the another form. Just like you had the electrical energy, it transformed into the sound energy. So you had a pre-existing energy. Okay, no? By the way, that pre-existing energy, that is the electrical energy, that also came from somewhere else, like the cell phones that uses the lithium battery. No, lithium battery has chemical in it. So there also it was transformed from chemical to electrical energy. So that is the case here. Hope you guys are getting this. This is a very fundamental concept here. Okay. Further, the question is how the sound is produced. How the sound will be produced. We'll be learning about how humans will be producing. First of all, let's take a look at this here. If you guys can look at this again, here you guys can see that the molecules of the air, no, the air molecules are moving in a to and fro motion. Just like the pendulum of the bob of the pendulum clock moves now, it moves in the to and fro motion, forward and backward, forward and backward. So does these molecules also not seem to be doing a forward and a backward motion? Look at this carefully. When all of you turn your cameras on in the class. So whenever we strike any given instrument, take for example, we strike this tuning fork here. Take for example, we are going to strike this tuning fork here. Look at the way how it is vibrating. It is moving in a to and fro motion. To and fro motion is forward and the backward motion is called as to and fro motion. So it does a to and fro motion. And when we strike a tuning fork, here it is going to do a to and fro motion. Or say for example, when you're going to stretch a rubber band, that also vibrates and that also produces sound. So due to the vibration of the object here in the to and fro motion, it is producing a sound. Whether it be these musical instrument or whether it be the vocal cord present in our larynx, that also produces sound because of the vibration. We know how the sound is produced by the vocal cords here. This whole structure is the larynx, also called as the voice box. Recently, you guys have learned about this in the previous class. It has two cartilaginous structure inside it. This cartilaginous white structure that you see, these are called as vocal cords. And vocal cords should be producing the sound as the air will be moving out of this now and moving into this. So it will be vibrating. As the air will be passing across the vocal cord, it vibrates. As I'm speaking right now, the air is passing through the vocal cords. It is passing across the vocal cord. And because of that, it vibrates and hence sound is produced.
So every time we speak, this will show this moment.
Exactly. Even if you were to speak very slowly, even if it is utter a small word, it will be vibrating. So every time we speak, it vibrates. Okay, now. So these are the two muscular kind of a structure that is present in our the larynx that will be producing sound by vibration. Okay, now that is, and they are also helpful in breathing as well. Okay, now that is one thing. So they allows us to make the sound. By the way, this structure that you were seeing here, this pipe-like structure, that is, what is it? It's the windpipe. Okay, na? And windpipe is the common name for trachea. Windpipe is the common name for trachea.
Yeah.
Okay. So that is one thing we have learned. So one thing is that we have learned it will be produced due to the vibrations, whether it be the vibration of the string instruments, or you guys would have seen that due to the flapping of the wings of the birds, also sound will be produced. Hmm. Or when the air will be passed via the flute, while when the air will be passed through this now through this flute, so the flute will also be producing sound because the air column of the flute will be vibrating as air will be passing through it. The air column in it will be vibrating, and because of that, sound will be produced. So that is something which we have learned, particularly if we were to learn about how the humans will be producing sound. So we humans have a voice box or larynx which is present in the upper side of the windpipe. It is present in our throat on the upper side of the windpipe. The larynx has two vocal cords, as you guys can see here. These are two vocal cords present here, and they have a narrow slit between them so that air can pass through it. So there's a narrow gap between these two through which air can pass. And as the lungs would be throwing out air out of the windpipe, as you will be exhaling out the air in the breathing, you have inhalation and exhalation. So when you will be exhaling out the air, so air is going to pass through the gap between the vocal cord, and because of that it will start to vibrate now. So particularly during the time of exhalation, what is happening here, the air passes out of the lungs, air is passing out of the lungs now, and as the air will be passing out of the lungs, it will start to vibrate. So that is the way how it produces sound. If you were to look at the structure and the size of the vocal cord, um, in the case of male and female, so we have learned that once male female they attain the age of puberty, once they are in their adolescence, the size of the larynx increases, so thereby the size and shape of the vocal cord, that will also be changing. Okay, no? Their thickness and their tightness will describe the quality or the type of the voice a person will be having. Getting it?
Yes, sir.
Say for example, if the if in a person vocal cords are more tight, so thereby their sound will be um, less deep, right now. So if they are more tight, they will be experiencing some kind of they can experience some problem also if it is unusually more tight. Like if it is strained, thereby the person can suffer from some pain while speaking. Okay, no? If it is strained, you guys understand now. If it is stretched, kind of stretched, so thereby it can affect the quality of the sound, like it can change the pitch of the sound, right now. That is one thing. So many times you will be it will be recommended by the doctor to take a humidifier. Many times if your voice is not proper, if after examination it is found that the vocal cords are stretched, so with the help of some moisture it can be relaxed back into the normal state. So a humidifier is recommended if someone is having a rough sound. That is one thing. Further, if you were to look at the case of the male and female, so in the case of male, they are of 20 millimeter in length, and females have 15 millimeter long vocal cords. And children on the other hand have very short length vocal cords, because of which the type of the quality of the voice in the case of men, women, and the children will be varying. And quality of the sound is mainly determined by the length and the thickness of the vocal cord and that of the larynx, particularly of the vocal cord. Hope that is clear to everyone. Further
Sir,
talking about the how this. Yes.
can you explain that again?
Okay, sure. What I was saying about the vocal cord, no? Vocal cords, as you guys can see here, this white structure, these white muscular structure, it is present in our larynx. This whole structure is the larynx, and this structure that you're seeing here, that makes up the vocal cord. Now, as you will be exhaling out the air, as your lungs releases the air back into the environment, so due to the passing of the air, like this is actually on top of the windpipe. Now, basically, it is present in our throat and it is connected to the windpipe. So air will be passing out of it, and because of the passing of the air, you can look how it is vibrating. So it starts to vibrate, and we know due to the vibration of anything, sound is produced now. So due to the vibration of the vocal cords, sound will be produced. Further, we learned that the thickness and the tightness of this vocal cord will determine the type of the voice a person has. If, say, for example, if it is very tight, if the vocal cords are very tight, so thereby the person's sound will be having a less pitch. It will be less pitch, having a less pitch now. Okay, now it will be not a very brilliant sound. Sometimes it will might sound croaky, like that. Or we use a common term called as hoarseness. What do we say?
Odds.
Let me write it over here. If the vocal cords are very tight, so thereby the sound will be it will be very a hoarse sound. Okay, no, so that is called as hoarseness. And doctor will recommend you to take to stay hydrated, or to take help or to take a humidifier. Okay, and that is one thing. Or many times you guys would have observed that if you continue to speak, if you were to continue to speak for several hours, your voice might start to break. Then you will be recommended to drink lots of water, drink lots of fluids, and give rest to your vocal cord, and don't speak too much. Might have happened with you guys. Further, we learned in the case of the males, they are 20 millimeter in length, and in females, it is 15 millimeter in length. And in children, they are usually very short. That's why male, female, and the children's, their sound quality differs because of the size. Talking about how the sound will be propagating, how the sound will be traveling. So in order to propagate the sound, in order for the sound to travel, it requires a medium through which it can travel. And this medium could be air, this medium could be liquid and solid. And sound will be propagating in a medium. How? As it will be propagating in the medium, the particles of that medium will start to vibrate. It starts to vibrate. From the starting point, you can see here, the particles have started to vibrate. Okay, na? And there will come a time when this vibration will stop. Will it continue to vibrate? Like for example, the sound is produced here. Even after 1 kilometer, will the sound will still be able to hear? Will you be able to hear the sound 1 kilometer away from this vibrating object? Usually no, right now, unless if it's a very loud sound. So it has a starting point, and it will be having an ending point also. Now, the ending point will be the point from where it will be no longer audible. Yes or no?
Yes, sir.
Yes.
So another important thing what we are seeing here, the propagation of sound in medium is required. Further, the sound will be produced due to vibration of the particles of that medium, and and it will always have a starting and as well as a ending point. So let me add that it has a starting and a ending point and an ending point. Like for example, take the example of this. Like if you are talking to your friend, to your family members, as you will be speaking, the particles in the air will be getting displaced due to the pressure that is caused by the sound which you are producing. Like what is going to happen, as I'm speaking right now, the people surrounding me, or you guys are able to hear me, particularly if there were to be someone in my room right now. So how he is able to hear what I'm saying, he or she is able to hear what I'm saying, as this will be vibrating now, as this vocal cord is vibrating. So this vocal cord is going to vibrate the air column in my mouth. Getting it, everyone, what I'm trying to say? The air column in my mouth, that is being vibrated due to the vibration of this. So actually, more specifically, we should say that the air particles in my mouth, that is being vibrated, and due to the vibration, the sound energy is traveling, and my friend or my family members or your friend can hear it. So when we are talking or when we are speaking, basically the particles in the air will be getting displaced due to the pressure that is caused by the sound which we are producing. And they are actually displacing the particles. They are displacing the surrounding particles. Their adjacent particles are being displaced. And how they are being displaced? They are being displaced in the form of rarefactions and compressions. So in this way, sound will be traveling from me to my friend's ear. Is that thing clear to everyone? What I'm trying to say?
Yes, sir.
Okay. Now, anyone who is having a doubt in this, please let me know.
No doubt, sir.
Okay. You guys tell me. Can we see that the particles are traveling from one point to another, or just they stay on their position and just they are vibrating on their respective positions? Is it that the particles from this point is moving towards the other point here? Is it going from point A to point B, or they are just staying at their original position and then just they are vibrating at the original position? What do you guys think?
So they're going from A to B.
No.
No?
The particles are Mhm.
They vibrate in the same place.
Exactly, they are just vibrating on their same place. Okay, na? Just like, for example, take the case of the pendulum, how it vibrates on the same position. It's not moving from one place to another. You can, in a similar manner, you can understand that all these air molecules are vibrating in this same position. It's not changing its location from point A to point B. So we can say that the particles of the medium, they do not travel from one point to another in order to propagate the sound. Sound is being propagated because of the disturbance that is caused by the source of the sound here. This source of sound here, it has created a disturbance in the medium, isn't it? Right?
Sir,
Yes,
doubt.
mhm.
Sir, we can see the adjacent particles with the help of microscope. Something.
With the help of microscopes. Yeah, you can see it. But usually with the help of the microscopes, what do we see? You will be required to take help of an electron microscope particularly. Okay, na? Electron microscope more specifically. Okay, and that also you'll be able to look at a very tiny, very tiny portion of the air column. No, you won't be able to look at it as a whole. I mean to say, you'll be, if you're going to observe it as using an electron microscope, so what you will be able to see, you'll be able to see just a tiny fraction of it. You won't be able to look at all the air molecules vibrating at once. Getting what my point?
Yes.
Okay, that is one thing. Further, can the sound travel through vacuum? It will not. It will not travel through vacuum because it requires the particles for vibrations. So that is the reason why sound will not travel in vacuum. Sound will not travel in vacuum because there are no particles present in vacuum for vibration to take place. So how will it be traveling?
Actual vacuum.
They can.
Like an actual vacuum.
Yeah, in actual vacuum, you're saying.
Oh, okay.
Vacuum basically in which there is no medium, in which there is no particle. When you go to the space, it is simply vacuum. So it cannot travel because there is no particles to vibrate. So this is something we have learned right now. How sound will be traveling in a medium, we have learned. Further, if you were to talk about the medium here, so we get to see that sound will be traveling, sound through the water will be traveling 4 times faster than the air. And sound through the solid will be traveling 13 times faster through the air. Meaning that if you were to look at the speed of the sound, by this statement, we can clearly say that the speed of the sound will be maximum in the air, water, or the solid air. Read the second statement. Sound through solid travels 13 times faster than through the air. Getting it now? So the speed of the sound is maximum in the solid. Now the question is that why the speed of the sound will be maximum in solid objects? Can you guys think of this?
The particles are tightly packed in solids.
Exactly. The reason is that the particles are tightly packed, they're compactly packed, because of which the sound will be easily transferred. It will be easily transferring through it. Okay, no? Okay. So the speed of the sound will be maximum in solid, it will be less in liquid, and will be the least in gases. From this statement, we can see that the speed, let me write it here, the speed of sound is maximum in solid, less in liquid, and least in gaseous medium. Now, take a look at these three different medium. Say that this is a solid medium. So what we will see that the particles of the solid materials, as we know, are compactly arranged like this. They are compactly packed. Then take a liquid medium. Like, it's a common thing. For example, if you guys ever went to swimming, and say, for example, under the water, if you were to struck something with a hammer, struck some metallic object with a hammer, will you guys be able to hear the sound produced? Or
Yes.
for example, if your friend under the water were to struck a metallic object or metal plate with a hammer, the other person in the swimming pool under the water, not above the water, under the water, won't be able to hear it properly, no? So that actually proves this thing, that how the sound will be traveling through the different mediums, particularly in
There
liquid.
are doubt.
Yes.
There in some places there are basements,
Yeah.
How the sound travels there? Like we
Okay.
can
You can hear the echo in the basement, right? You're
yeah.
talking about that. Okay. So, like for example, now I will be getting that to getting back to your question in a minute. Let me just complete this one. Okay. There actually the concept of echo, we'll be learning about that. If you were to look at these three different medium here, respectively solid, liquid, and the gaseous, and here we can look at the particles, how they are arranged. Say for example, if I were to hit them with a hammer, each of them has been hit by a hammer, and there's a person on the other side who is trying to hear the sound. This is the ear I have drawn here. Okay, now. So clearly we are going to see in the first case, in the solid medium here, when this object will be struck with the iron hammer, the particles will start to vibrate, and due to the vibration of the particles of the solid, energy will be quickly transferred to the another one like this, right now?
Yes, sir.
And there is less gap between them, so hence energy will be quickly transferred to the other side of the solid medium, and hence we'll be hearing the sound very fast in this. Sound will be traveling very fast in this medium. But in the case of the liquid, remember the example of the you hammering a metallic object under the water. Your friend will not be hearing it properly because the speed of the sound is less, and some of the energy is lost into the water as well. So thereby, the sound will be traveling here. It does not mean that it is not going to travel, but the speed of the transfer of the sound will be less. In the case of the gases, it will be very low. It is least in the case of the gas, because you can look at the distance between the particles here. You know, Abdullah, can you rephrase your question?
Yes, sir. Sir, how can we hear from basement? Like why this echo? Like,
Okay, okay. See, the thing is now, like there are certain places, particularly in the basement, for example, when you speak something, or when a sound is produced, when you struck something, a sound is produced, so the sound waves will be reflecting from the walls of the basement, it will be reflecting from the surrounding surface, and it will return back to the listener. It will return back to the listener. Getting, take for example, you are in a basement, say for example, and you are saying something, for example, You have spoken something. So these sound waves are going to get reflected from the wall of the basement. Not just from the one wall, but from the four walls of the basement, it will be getting reflected back. And after getting reflected back, these will be returning back to you. See, for example, these are the sound waves. It is getting reflected here. And after reflection, it will return back to you. These are the returning sound waves. So because of this, the echo is produced, and that's how you're able to hear the sound in the basement. And the sound that you'll be hearing, it will be more than once. It could be more than once. Many times it could be repeated. Many times you guys have seen that if you were to go to a very high cliff or you are in a basement, you can hear your own sound multiple times. Ever happened with anyone?
Yes, sir.
Yes,
Hmm?
sir.
Hmm.
Right.
So they're basically reflection of sound will be taking place. And if the reflection takes place multiple times, you'll be hearing your own sound multiple times. If reflection happens 2 times, 3 times, 4 times, you will be hearing your sound 2, 3, or 4 times like that. So hope that clears that out. Okay. Further, talking about how do we hear the sound. Moments ago, we learned about how we produce the sound. Okay, na? So talking about how we will be hearing the sound. So let's say that there is any source of sound. For example, there is a loudspeaker here. So as the sound will be produced from this loudspeaker, so in the form of compressions and rare fractions, it is going to travel inside our ears now. So you guys tell me, what is the term used for this when the sound waves are very compactly packed? They are very close to each other. What do we call this? Do we call this compression? Good. And the other one is? Yes, what is it? It's a rare fraction, no?
Yes, sir.
Rare fraction. Okay. So here we're getting to see that as the sound will be produced here, the sound will be produced. So the particles of the medium will vibrate in the form of compression and rarefaction, and the sound energy will be reaching to our eyes, to our ears, I mean to say. And when we look at the structure of the human ear, it is divided into 3 parts. This is the outer part. There's the middle ear, and then there is the inner ear. The inner will later on we'll be learning about this in detail, by the way. As of now, just let me tell you what basically happens here. Your outer ear will be catching these sound waves. The outer ear will catch these sound waves. You might have seen that certain animals have a very great sense of hearing. Like for example, elephants have a very big ear. huh? Elephants have a very big ear, and that actually helps them in hearing the sound. Like it has some other functions also. It helps them to stay cool also, but it helps them in hearing the sound. Like they can hear very low frequency sounds also. So the larger the ear pinna and the lobe, larger the size of the ear, they will be able to hear the tiniest of sound frequencies. They will be able to hear very small sound with very low frequencies. Nonetheless, if someone were to ask you what is the function of this outer part of the ear, ever thought about this, by the way? What is the function of the outer part of the ear? Basically, this I'm talking about the ear lobe and the ear pinna. You guys ever thought about what is the function of these?
Sir, it directs the sound waves to the ear canal.
Exactly. Directs the sound waves to the ear canal, or it will be basically helping to collect the sound waves. It will be helping to collect and direct the sound waves into our ear canal. Now further, as it will be passing into the ear canal, after that it is going to strike the eardrum. Now you guys know about the eardrum, obviously, right? Now eardrum, that is going to further vibrate. It is similar to that of the membrane of the actual drum. So there is a membrane in this, and that is going to vibrate further. So if the let me tell you this thing, that the vibrations are going to travel inside the ear.
Eardrum is too delicate.
Yeah, it is very delicate. It is very delicate. That's why, for example, if there's a very loud sound, if you are standing next to a loud speaker, so you might suffer from some ear pain also. Why? Because the vibration of the eardrum becomes too intense at that time. It increases very much. Getting all of you what I'm trying to say? Now, further, what will be happening now? As your ear lobe and the ear pinna, the outer ear has helped, it has directed the sound waves into the ear canal. Now, these sound waves are going to hit the eardrum, and the eardrum is going to start vibrating further. And due to the vibration of the eardrum, now the sound will be amplified. Getting my point? What I'm trying to say? Sound will be amplified further. Now the sound will be amplified further, and then it will be from here. Now the sound is going into the middle ear. Now in the middle ear, you guys remember I told you that there are tiny bones present in our ears. Tiny bones are present inside the ears. So there are 3 tiny bones in our ear. They will also vibrate further. The eardrum has vibrated, and the vibration of the eardrum is going to vibrate the tiny bones in our ears, and here what is going to happen now? The sound will be amplified. You guys know about the amplifier now? In the loudspeakers, there's a option of amplifying the sound. You can increase the sound, loudness of the sound can be increased, right?
Yes, sir.
So here, in particularly in your middle ear, the sound will be amplified because the bones present inside your ears, they vibrate against each other. And further, because of that, the sound will be amplified. And as it will be going into the inner ear in the form of electrical signals, it will be sent to your brain, and your brain will be interpreting that sound. So that in short, I have explained you how we are going to hear the sound. Later on, while we'll be learning about the structure of the ear, we will be learning about that in detail. Okay, no? Is that thing clear to everyone what I'm trying to say here?
Yes, sir.
Okay, no? That is the thing. So we'll be learning about some special things like the wave and the particle motion of the sound in the previous class. When the plane is going, yeah, that is basically Roni. Our ear will be hurting because if there's a very loud sound, so thereby the vibration of the eardrum will be very intense. It will vibrate too much. Okay, now. So if the vibration of the eardrum is beyond its capacity, it will be vibrating intensely. Because of that, it will be very painful. That's why you might have heard that you might have experiences sometimes. Or this. Okay. Now you guys answer some of the questions from sound to me. Do tell me, does the sound require a medium to travel? If yes, why? If no, why? Yes, guys, I guess I'm audible to everyone.
Sir, it does require a medium to travel.
Exactly. So if as it requires a medium to travel, okay, so why it cannot travel in a vacuum? What is it that the vacuum does not have?
There is no medium in vacuum.
Specifically, what is it that is not? Be specific. The particles are not there in the vacuum, no?
Yes, sir.
If there are no particles, there will be no vibration, hence sound will not be propagated. Okay, do you guys tell me that in which medium the speed of the sound will be maximum? It will be fastest in which medium?
A solid.
The solid. And in the decreasing order, list down the three mediums in the decreasing order.
Air,
Gases,
Decreasing order, decreasing order.
like
Okay.
liquids
Shakrika,
and solids.
repeat again.
Gases, liquids, and solids.
I haven't asked in the ascending order. You are saying in the ascending order.
there are solid, water, then gases.
Okay. Solid, liquid, and then the gaseous medium. Okay, now that is one thing. Okay. Further, if some like animals like elephants, they have a very big ear. What is the advantage of having a big ear?
They can hear very like small sound, vibration of sounds.
They
They
can sound from far.
exactly, and basically they will be able to hear the sound of very low frequencies, right? Now? So that is one advantage in them. By the way, you guys tell me, does the sound follow law of conservation of energy?
Yes,
Yes,
sir.
Yes, it follows the law of conservation of energy. And as per the law of conservation of energy, what do we know? That energy can
Not be
not
produced on its own.
so energy can neither be created nor be destroyed. It is just changed from one form